Hi, and welcome to Week 7, Part 2, Video and Audio Podcast. This time, we'll start with Section 4.1. In 4.1, we start looking at Pythagorean theorem. So let's put the abstract idea of infinity behind us and move on to geometry. 4.1 reintroduces us to the Pythagorean theorem. Many of you can rattle off a squared plus b squared equals c squared, but we really don't know why we're squaring a, b, and c, and we're not sure what those really represent. We just know that we were taught a squared plus b squared equals c squared. In your textbook, they talk to you about the proof of the Pythagorean theorem with 5 pieces of paper or cardboard. 4 identical small right triangles, which are represented in the upper left with the red, and 1 small blue square. Looking at these ideas, the square on the left represents c squared. Each side is c, the hypotenuse of the smaller triangles. On the right-hand side is an L-shaped made up of the 4 triangles and the square. Those represent a squared plus b squared. Looking at the bottom of your screen, I have covered up the individual pieces of paper lines so that you can better see c squared on the left, a squared and b squared on the right, meaning that the areas of these pieces of paper do not change by simply rearranging them. Now, let's take a look at a little different model. Looking at this model, you can see that if we draw a right triangle and draw a square on top of each side length, we get a squared by b squared and c squared. If we were to draw these on graph paper and cut them out, lay all of the a squared on top of c squared and all of the b squared on top of c squared, we would find that the areas are equal. This was used back in ancient times by Pythagorean's peers that were surveyors of land to decide which landmarks marked each plot of land. Now, for your question of the day. A baseball diamond is really a square measuring 90 feet on a side. How far does the catcher have to throw the ball to get it from home plate to second base? Please post your answer on Course Connect. Here's your next question of the day and the introduction to 4.2. Here's a floor plan of an art gallery. If you stand on the corner marked A, which walls or parts of the walls do you think you could see? That's right. The shaded area would be what you could see standing in point A without being able to bend your vision around the corner of a wall. Here's another question. If 3 people stood where the red dots are, or 3 cameras were installed where the red dots are, what walls would be seen? Standing in the first red dot, to the left, you would see everything that has been shaded in yellow. Next, moving to the dot in the center, you would see everything that has been shaded in blue. Notice that your vision is not able to bend around corners. However, you are able to see the entire point. The final red dot would be, you would see everything colored in red. Now, combining all 3 cameras, the entire art gallery could be seen. The idea of the art gallery theorem is an interesting one because it was relatively recently discovered in the 1970s. And the art gallery theorem states that suppose you have a polygonal closed curve, and in your mind that's just any polygon, a multi-side shape, closed, where you have clearly an inside and an outside area. If you take all of the vertices, which are called V, divide by 3, you can find the number of cameras or people needed to see the interior of the polygon. If V divided by 3 is not an integer, then you simply do not round. You use the whole integer, or in your mind you might want to think round down. Looking at this shape, this represents triangulation. Any polygonal closed curve can be divided into other smaller triangles. A small triangle represents the smallest polygon possible, 3 sides, 3 vertices. Would take one camera to see any part of those vertices. By coloring the vertices in 3 colors, you can represent each of the triangles. I hope this video helps introduce 4.1 and 4.2, and that you'll now take the time to read your text, practice the Mindscapes posted on Course Connect, and answer the questions of the day. Again, there's one more video in this sequence for week 7, so please proceed to video number 3.